Hello, welcome to another hopefully exciting CosmoQuest office hours. I'm your host, Pamela Gay, and I am here to try and destroy a world as it orbits the star Kelt B. Tonight, I'm going to be attempting to finish a animation that has been kicking my butt. So hopefully tonight things will go a little bit smoother. Now before I get started, I heard glorious noises while I was doing some last minute hiding of random things in the background. And I would like to thank Fenmill for being a glorious human being once again. Thank you so much, Fenmill. Can we get some rockets out there? Can we light this place up to honor Fenmill? And let me see if I can adjust my lighting just a little bit so I don't look as allergy-ridden as I actually am. It's a little bit better. We'll see. Okay, so do we have any questions before I go ahead and get started? Thank you, Fenmill. You know, I hadn't thought of that silent searchlight, and that's now going to bother me. Thank you, Paranor, for the subscription. Excellent, excellent. So can we get some more rockets out in the chat this time for Paranor? All the rockets. Okay, so to bring you all to where we were before, I have been attempting to do an animation of the planet Kelt 9b as it orbits Kelt 9, and Uncle Bill, that is the best abuse of emoticons ever. I'm doing this in a framework that sits on top of Java, and here we go. Oh, you guys are getting an echo. Okay, your audio should be better now. So here is, without the star, our happy little shadowed planet going round and round its invisible star. And the shadow is behaving nicely, behaving nicely, behaving nicely. Go, 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 little planet. Do your planety thing, planet. And now it begins to grow hair instead of getting a shadow. So we need to fix that. Yeah, so Colonel John, my only memory of punch cards is being given my dad's broken code to scribble on with crayons. That is a dead giveaway of my age. Now, for those of you who don't know what Kelt 9b actually looks like, let me pull up a kind of stunning image. So this is the actual Kelt 9b system. It's only an illustration. I love that in our modern day and age they have to say it's only an illustration. These are the actual colors. Let me turn our star back on and increase. Trying to figure out what lighting to deal with. My phone is somewhere missing in the house, so I can't adjust my lights the way I normally do, which is the most first world problem ever. Okay, so we have Kelt 9b, and I'm going to bring back my star. Now, I had erased my star last week just for the sake of being able to figure out what the heck was going on with my planet, my misbegotten, misbehaving planet. So here is Kelt 9b, and I have to say the illustrator who did this totally left off the limb darkening. It's not too bad an illustration. Their planet's way better. Way, way better. So back to trying to sort out. So John, I can draw hair, just maybe not on you with this program. So Silent Searchlight, it was more a matter of, I know it's in the house, it's not in this room, and life is short, and I needed to go live, so I decided to simply curse at my lighting. There, that is better. Oh, Fenmil. Okay. Returning to my code. So the misbegotten part is this back left. And let me make my screen a little bit wider. Ooh, doesn't want to fit. Let me make my window fit a little bit better. The more complicated my code gets, the harder it is to share it all with you. Okay, we're going to do this in 2 steps. So I'm going to make it fit that way. Now I'm going to move it. Who needs line numbers? Oh, apparently the line numbers want line numbers. There we go. Okay. So somewhere in here, I have a sign that is completely wrong. So what I want to do is change the left-hand illumination from 0, or in this case, the left-hand shadow. Let me change this. The left-hand was correct. Left-hand shadow from 0 to 1 as the planet goes left. Now, what that means is I want to, as I do my step from 0 to 100, marking across the surface, I want to make sure that my planet diameter goes from 0 to 1. And as a sanity check, the first thing I'm going to do is delete that. And what I'm doing now should just draw a single arc. Now I'm going to go ahead and kill off my star again, because who doesn't like to kill stars? Killing stars is totally what it's about. And I'm going to tweet this too. Wanna destroy a world? Work out your aggressions on Twitch with me as I destroy Celt 9B. I didn't mean to rhyme, it just kind of happened. There we go. Tweeting that out. The chat has now confused me. This is your right. You're allowed to confuse me. I'm just going to go back to saying at me if you want something. Okay. So turning the star back off, because who doesn't want to destroy a star? So there goes my star. And here goes my orbiting planet. And it's right there when it goes through the center. The power of coffee in a Jedi creates the greatest force. Now, if any of you want to go back and figure out how the heck we got to where we are today, all of these episodes should be going up on YouTube. Okay, so we are successfully drawing the outer part. Now, the next thing that we want to do is, scrolling back to where we were, I'm going to draw the other arc we need separately and then figure out how to mathematically get from one point to the other. So this one is going to be 0. Now what I should be able to do is draw half a circle. I wish I had some vague control over where it decided to draw this box, but it just wants to draw wherever it feels like. I have never had a Nintendo Silent Searchlight. I had an Atari 800 a million years ago, and my husband had an Xbox for a while, and I used it mostly to play Lego Star Wars. Oh, okay, that did not go in the direction I anticipated. I made the height 0. That was wrong. Let me fix my mistake. So the way this command that I'm using works is it says draw at these XY locations and then draw an arc that is an arc on an ellipse that has 0 radius in the X direction, has a it has 0 diameter. In the X direction, has a given diameter in the Y direction, and draw the arc on a circle that uses radians. We can all kvetch about radians together, that goes from pi/2 to 3/2 pi. So hopefully I'm now going to draw a half a circle. We had a Wii at one point. I really loved my Wii. Oh, Fedmill, you just... Thank you, Canada Kim. That is excellent. And your giant stars scared the planet into orbiting the other direction. You were the force, the invisible force that changed this planet's orbit. Okay, so it's doing the thing. It's like drawing the half a circle. Okay. So I need to say, light up the chat with rockets. Oh, we have a raid. Where is this raid coming from? Hello, Deprist15. Hello, all the other newcomers. Those of you who don't know what you've just wandered into. Hello, Drop Bear. Oh, it's coming in from Horizon side. Excellent. So there's going to be more people invading. I better turn the sun back on. Okay, turning the sun back on, because who doesn't want a star? Hello, denizen of Earth. Emote, emote, emote. Let's all emote together. Welcome everyone joining us from Silent Searchlight stream. You are joining me just in time. It's actually an astronomy programming stream. Words, they're hard. We are currently in the process of, I have drawn the star Kelt 9. We have a planet, Kelt 9b, going around the star, and I'm trying to get all the perspectives correct. So welcome, thank you for all the followers, everyone. The reason the star just disappeared is I'm trying to get the shadow to work right on the back side of the star. And currently, my accursed planet shadow doesn't work. So I'm going to move my planet shadow to the bottom of the screen so I can be reminded. Actually, I'm going to move it to the top of the screen because that's how my coding window wants it to be. So there is Kelt 9, and Celt 9B, and there is my code. And what I'm trying to do is figure out how to mathematically step using the variables I've got from having, there it goes, from having a line down the center to having a line on the inside, and I need to fill in between those lines. Thank you everyone for the follows. This is really fabulous. For those of you who are new to this, my work, thank you guys. My work focuses on figuring out how to engage everyday people in learning and doing science. And yeah, welcome, and I shall science you, and I shall astronomy science you. And you are all encouraged, well, to follow, first of all. Following is fabulous, but beyond just following, you're encouraged to go ahead, ask me astronomy questions while I'm doing this. Just please at me as CosmoQuest, or I won't see you. So Celt 9B, thank you. Thank you, all you humans. You're fabulous. So Celt 9B is the hottest planet so far discovered. It is orbiting a words, they're hard. It's orbiting round and round a giant blue star, and it's so close as it orbits that its surface is getting heated up to the temperature of a red dwarf star. Celt 9B is mostly just a hot star, and the reason the star keeps disappearing when the planet's going that way is so I can figure out how the heck to fix my code, because I am having trouble getting this particular shadow to behave as I wish. Now the problem that I'm having is I can't get it to only illuminate as much of it as it is supposed to. So I'm going to go ahead and see if I can get just the illumination angle, just the part of this that decides where the inner part of that shadow goes. So the reason I have this green stick is to give you a sense that this is a planet that's rotating. Let me, because I'm a nerd, I actually have a bowl of planets in my desk. Oh, the planet is a gas giant, yes. Okay, so here we go. A literal bowl full of planets is in my desk, because who doesn't want a bowl full of planets? So our superheated gas giant, I want to keep track of how it's rotating as it goes around and around and around. And the way I've done that is I attached a stick. And so depending on the orientation, you either see just the tip of the stick, you see the stick sticking out, or wow, I have no coordination, or you see no stick at all. So the stick allows us to get at the rotation. My shadow colors will be fixed once I figure out how to get my shadow fixed. And the reason I'm so frustrated is I have this working everywhere else, and I'm just not sure why it won't go. And what it's leading me to believe is that there's something wrong with my illumination equation. And this is why I'm breaking it down step by step to try and figure it out. And I think the problem is that this should be earlier to get things to work. I did 50 minus step because 50 was my max value. Down here I screwed it up, and what I should be doing actually is step minus 150, or actually I probably want to do 200, which is my next boundary, minus step. I bet if I do that, everything will suddenly work. And I am so convinced that will be true that I'm going to live dangerously and copy my entire equation back in. Oh, it could be another infloat issue. That is true. Thank you. Thank you. This is a tightly cast language, and I have magical abilities to abuse my variables and make them think they are whatever I feel like they should be at that given moment. And that doesn't work. I need another parenthesis. And I needed the illum I just deleted. All right. So around and around and around our planet goes. Where it will end up, nobody knows. Now, if we can get this to work, then I can begin shading my shadow so that it looks prettier. So you can see it's going away, it's going away, it's going away. It's gone, and it came back and is going away backwards. So I think that means that I just need to change my sine to a cosine. I can do that. Let's try that. So I have been breaking my head against this problem for the past 3 weeks because I was certain that my typo was down here in my for loop. And no, the whole time it was just sitting up here, and I was simply failing to step through and do the math up there correctly. So let's see if this works. Go, 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 grow, grow, little shadow, grow, and nailed it. Okay, so now I can just put my star back, and now we can do the cool stuff, like making that shadow not look like a play school helmet. So here we go. Hey, Ornerus, welcome. Thank you, Silent Searchlight. Okay. Now, to try, those play school people did have great hair and they didn't have to worry about strong winds. So with this particular system, we have the bright blue because it's a hot star. Hot things are blue, cold things are red. Every children's coloring book ever lied to you. And the shadow is simply caused by the planet isn't illuminated on both sides. My eventual goal is to have the shadow at its darkest as it goes around the back, and as it comes back around the front, match our cosmic latte, extraordinarily dark cosmic latte background. This is just Celt 9B. It doesn't have any nicknames yet. So let's see what we can do to shade our shadow now that I have it working. And I'm actually going to start with the accursed part at the beginning where everything broke. No, I'm not. That's a lie. I'm going to start at the very beginning where everything didn't suck. So I'm going to comment this out because well, you have to comment if you like yourself. Otherwise, your future self is going to feel unloved as it tries to figure out what the heck you were doing And yes, thank you for the reminder to save. I'm so used to working in the cloud that I completely forget not everything just saves automatically all the time. Okay. Looking about on my screen to see if I have my colors stored anywhere. I don't. So what I'm going to do is I want shadow to start at color of planet, shadow end dark. Let's go ahead and start making this our Cosmic Latte color. Now the trick is I don't know how I made the background anymore because I made it so many weeks ago. So with processing, you get to set up your window, tell it how big you want it to be, and set up all sorts of different things, and then tell it to draw. And I apparently made my color in 2 steps, but that's okay. So the way I did this before was I created a background that was pure black, and then I put a 63% opaque Cosmic Latte color on top of it. Thank you, Noel. That's awesome. So the way I'm going to figure out exactly what my background color is I'm going to cheat. I'm on a Mac, so it's super easy to screen grab. I'm going to screen grab a chunk of my screen. I'm going to open that chunk in Photoshop, and I'm going to make Photoshop tell me exactly what color my background is. There we go. So once I know what color it is, once Photoshop opens all the way, I think I may have just hit my computer's end of happiness. And can we light up? Oh, you did light up. Thank you for lighting up the chat with rockets. That is the best thing you can do right now. There we go. Okay, so my color for my background, I'm just going to fill it in. I'm going to make my life easier from here on out. The color of my background in RGB is 63, 61, 57. And that is our Cosmic Latte layered on top of the blackness of space. So if you don't know what Cosmic Latte is, first of all, give it a Google. Cosmic Latte is the average color of all the photons of light that are spread across all of space. Now, the reason we don't see our sky as being beige in color is because there isn't something to illuminate the sky in every direction we look. This is called Ober's paradox. It was one of the first arguments for why our sky is black and why our universe is not infinite. The argument is that if our universe were infinite, no matter what direction we looked in, at some point our eye would rest upon a star, a galaxy, something generating light. And that would mean that every single direction we look in is bright. And since we have darkness, since we do have night, it means our universe can't be infinite in both space and time. And when Omer came up with the paradox, we didn't know that the universe wasn't infinite in both space and time. And so he looked at our universe and looked at the darkness and said our universe can't be infinite, but all the philosophers and scientists say it is, but it can't be. And thus Ober's paradox. So the average color of the light where there is light is beige. But the reality is, yeah, the reality is the sky's dark, man. The sky's dark. Okay, so that was not actually what I wanted to do. What I actually wanted to do was say, these are our target end colors, and I'm going to go ahead and figure out the color of the planet, which should be up here under planet, shade planet. Okay. Right side. So if we could see, I think I stopped shading it at some point. Fill. Why, yes, I did. I have a solid colored planet. At some point I will have to fix my solid colored planet. This is again why you take notes. Now, the colors that I'm looking at, these are colors that are drawn from the temperature of the world. As I said, this particular world is super, super hot. Now, it's really hot mostly on the outside, which is kind of weird to think about. The inside can't be as hot, or the sucker would be a red dwarf star. So it's superheated on one side, and then stuff and things happen. Now, I'm skipping around. In order to go between all these different things, what I need to do is transition between colors in 100 steps. Now, the reason I'm saying do it in 100 steps is because the steps I have between each transition are 100 steps, so that just seemed to make sense. Okay, so I'm going to transition between these things in 100 steps. This means that for how my red color, for instance, changes, and I'm going to make sure that that is a universal variable. It's not, so I'm going to have to declare my variables, and that is fine. I will do it grudgingly. So my change in red with every step is going to be 255 minus 63 divided by 100, and as always, I forgot to actually make things floats. I will confess, I am, at my core, a PHP programmer. You may call me names. It's just the way my brain wants to work. I know PHP is a lazy language, but lazy language is another way of saying it's a language that lets you get shit done quickly and easily. And who doesn't want to be able to do that with their day? Now, I have also been programming in Python, which is why my semicolons decided to go missing. One of the problems with being a good programmer, or at least a good enough programmer, is you eventually end up working in multiple languages, and just like anyone who's multilingual, your brain occasionally forgets exactly what language it's supposed to be working in, and weird shit happens. Okay, so here is the last of my deltas. Now, what this means is for the one of these that is incrementing every step, right hand illumination from 0 to 1 as goes to center. Trying to figure out what I did. The reason I'm staring at it like this, oh, the left is already shadowed. That's why. Okay, never mind. Figured it out. Okay, so this is the arc that changes. So at step equals 0, it draws center. So that means that it's going to be drawing things in the order of, let me confirm that. Step equals 0, sign equals 0. Yes, okay. So at step equals 0, then sign is 0. That means it's drawing a straight line down the center. So it starts with the straight line in the center, and then it adds individual points with each time that it goes through. Excuse me while I become slightly confused. So this is drawing a solid object. It's not drawing individual arcs. Crud, I have to change this to drawing individual arcs. Okay. So the reason I just made all the faces, why are you bringing up Ethan Siegel? Oh, because that's his article. Yeah. The universe, we think the universe is finite. It's at least finite in time. We don't know for sure that it's finite in space. So yeah, we do know that we can only see a few % of the total universe, and the reason we're able to figure that out is if the universe were smaller, we'd see a larger percentage, and some of that universe would have had time for the light to travel in 2 different directions to reach us. Some of the light would be coming at us from one direction, some from another direction, because our space is actually shaped like the surface of a donut, and you can go around the surface of the donut in multiple different directions. Now, since we don't see the same pattern of light in any direction across the sky, that tells us that donuts are the superior shape, and we're only seeing a few % of the universe. Now, it doesn't tell us the universe is finite. We know it's finite in time because there is a Big Bang, but we just don't know if it's finite or infinite in size. We just don't. Okay, so the reason I was making faces is I wanted to step through the colors, and down here I'm drawing things one arc at a time because that way I can draw the skinny crescents. Now the software lets me draw, so it lets me draw, I'll tell you what I can draw. That shape, it lets me just draw that shape, and it lets me draw the straight line with an increasing radius other side. Those are built-in functions. Now, when I get to the back side of the star, it's all crescents all the way down. So I'm going to figure out the shading looking at the crescents first. And I'm just going to grab my comments and copy them down. I will probably be moving my comments all over the place while I figure this out. Actually, that can go outside of the loop entirely. I don't know what I just did. Control-Z. I meant to cut some code, and then it was just like, no, I'm not going to do that. Pardon me while I try and figure out what it did wrong. Okay, so I didn't cut what I meant to cut. So here I go, grabbing my comments and my information on how you step through the colors, and I'm going to add the word shading so I can find this later. I'm gonna fix my indentation later and let it completely bother me for now. So I need 3 variables called RGB that are my starting values. And these are always going to be based on the color of the planet. So my starting R value is going to be 63. I'm programming an animation, Alan, Twitch TV. I'm actually doing planetary science. You can ask me planetary science questions. So this is Kelt 9b. This is the kind of star that when I first started doing astronomy, I was told, oh, big stars like that will never have planets, which is hubris on the part of men, by which I mean the universe likes to tell us we don't know what we're talking about by proving us wrong over and over and over again. And this system that was never supposed to exist was also discovered by someone I was an undergraduate with. He was a year ahead of me, Scott Gowdy. And I remember at one point how he had no idea how old I was. And I was taking what was supposed to be a junior level astronomy class my freshman year. So this is my first semester in university, and I'm in a course you're not supposed to take till your 3rd year. But whatever. So here I am in this class, and plowing through the content, and there were 70 people in the class. By the end of our astronomy program, there was 6 of us. And at one point, Scott, in frustration, while talking to me about the homework, just let loose about how he couldn't believe here he was, one of the youngest in the class, and everything was so easy. And I kind of looked at him and said, I'm a freshman. And he had one of those looks. That's all I'm going to say. But we got through a lot of years of that course together after surviving that first semester. And he went on to have the most tremendous career of any of us that took that astronomy class together. Anyways, this was found by someone I went to undergraduate with, and like me, took all of his classes far younger. Yeah, Silent Searchlight, that's a good description. I just ruined his day by making him no longer the youngest. But he's brilliant. He deserved in every way to be there. Okay, so I'm now trying to figure out, I have my RGB starting colors. This particular star is starting its steps, so I'm working on the back side here. And as it does this, it's going from I equals 0. So it's drawing I equals 0 to 100 times the illumination angle. So the last thing it draws is going to be the inside part of the shadow. So I always screw up how to fix the stroke color, but I know I did it in here somewhere. So where did I set that? Maybe I didn't set that. Maybe I lied to myself and just thought I set that. There it is. It's stroke is the command I want to use. Okay. So I'm going to set my stroke color to R, and as I said, it's going to draw first the centermost part. So I want this to be R. Man, I'm doing this to myself the hard way, but at least it's consistent. R is the color of my planet. That's the part it does first. When that equals 0, sorry, I'm working through the math in my head here, and as I've proven many times, I'm really bad at doing math in my head. So this is going to do the outermost edge first. So I actually want to be 100 minus I times delta R to get to the correct color for that one. And then I want to do the exact same crazy math for my G and my B colors. And if I do this right, I'm going to have a beautiful slow changing R. I sound like a pirate as I talk through this. I'm going to have a beautiful slowly changing shadow. Okay, here we go. Duplicate local variable del R. Okay, so apparently I already declared my variable. I just forgot I declared my variable. Del V cannot be resolved into a variable because it should be B. My head is getting stuck in astronomy land where V and G are the same letter. Now, unfortunately, we're going to have to wait for this to start going around the other side. I'm glad you think this is cool. Art is passion. Now, hopefully, my color blending, whoa, that was totally not right. I need to erase my star again. It's just nice to know I have power over stars, at least in my simulation. Okay, let's try that again. I think I did my color blending backwards, which is totally a thing I would do. The heavy sigh of having to wait for orbital rotations to complete. Boom! Totally did that backwards. Okay, let's kill off some things. Boom! Okay, let's fix that. I did this half. I don't need the 100 minus. I just need to have step. Okay, cosines and sines are going to be the devil of me. Wait, did I just change the wrong thing? I totally just changed the wrong thing. Maybe. What did I change? Yeah, I did that wrong. Ignore the stupid human tricks. I needed to get rid of these 100s. Whoa! It's growing hair. I will remove my eyes from their crazy and unnecessary parentheses if this works. Go planet, go planet, go planet. Come on, keep going. It is a Beardy McBeard planet. Yes! Okay! The radius is somehow not quite right, but other than that, it worked. It worked. All right. Okay, let's add this exact same chaos other places and see where we need to change the signs. So I'm going to add that here and see if I can get it to do other cool things. Oh, yes, I do need to save now. This is true. This is true. Thank you. I lost work once, so I have to be reminded. My staff likes to say I am not to be trusted with physical reality. Okay, come on, come on. You can do it. Got it? Okay. Going more crescenty, and we're out. And coming back, coming back, coming back. Okay, so now I need to figure out how to get my added math going in other places. Now we're coming up on 9 o'clock. I'm gonna try and do this, but I leave myself space to fail miserably. So the first thing I'm gonna do is work on making this part here be drawn using arcs instead of being drawn using just a regular old shape. Now the other thing I'm going to do is I'm going to set my color for the shadow for everything to this darker color so it doesn't look quite so dumb. So let me go ahead, complete that. Maybe give it some commas because everything works better with commas. I'm going to make my outer stroke the exact same color because I think that's where I'm running into problems. Okay, so here we go. No, I just made everything the same fleshy tone as the planet. I meant to make it the same shadowy tone of the shadow. So I am now drawing shadows in the same color as the planet. And that really doesn't work. Really doesn't work. Okay, that should work better. Let's try that again. Oh, no. So I can't physically deal with physical reality. The key is I am expert with cyberspace. So it has been determined that for the good of everyone, I should limit my interactions wherever possible to virtual realities. Okay, so I at least now have my shadows all the same color. Alrighty then. I'm actually gonna not change that. Okay, so here I am. I have my arcing bit. I'm gonna come down here, grab my for loop and see what hell thing occurs if I just replace my arc with the command I used below. I know one thing I will have to do. That didn't look right. Nope, that was right. Is ignore the pain of my for loop spacing and check my angles. So I'm going from 1/2 pi to pi. I don't remember if that's what I had before. I should have looked. No, it wasn't. So I'm actually going to put my for loop in beneath so that maybe I can see what I'm doing and not screw it up. So for drawing my shadowy bit, I need it to draw the other side, so it just has to do different kinds of arcs. Everyone should be their inner neutron? Is that what we're saying? I did something very wrong. I did something very, very wrong. Okay, let's look at the code while contemplating the wrongness of what I did. So this, when I equals 0, it's drawing the full diameter. So this is where I need to do the 100 minus I. Knew I was going to have to do it somewhere. No. That did not go as planned. Not at all. Okay. So that tells me, so I know my illumination part is correct. I need to do the opposite of a crescent, which I think is that. So the shadow should be growing, and the planet should be growing. Pardon me while I stare very hard at my code and see if this is a smooth-ish transition. Pretty sure it won't be. No. So this is now more one. Yeah, the planet, the shadow is bigger than the planet on the back side. I have to debug that. Yes, I have created an acorn, and it is smooth like a 5 o'clock shadow on someone of an ethnicity that readily grows a beard. Okay, so I've started to hit problems I know how to fix. It's not to say they're going to be easy to fix. The issue is because I have a smooth gradient where it's gradiating out to the midpoint. It always appears to be less of a color change than what it actually should be. So what I think I want to do is actually divide my color change by 2. Let me try that. I want to divide it by 2.0. And hopefully this software actually does maths in the correct order, or I'm going to be sad. The software likes to make me sad. I should just make everything afloat by default. It would make my life easier. So this will cause things to get lighter slower if I did this correctly. Okay, yeah. I know this side of the planet works. Go, 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 go. Slowly orbits the planet. Okay, so we have bright, and we have getting darker, getting darker, getting darker. That did not work as intended. So when it's getting lighter, or helium paranor, or helium. So when it's, let's watch this transition here. So that transition needs to be divided by 2. This one, I think, this is front left motion. This one, I think, needs to be multiplied by 2. We're now hitting the aesthetic part of the evening. Not actually sure. So back left, back right. Let's start with the back right. I have no clue if this will work. Let's find out. Go, 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 go. Got it? Thank you for saying that, Quinn Culver. Okay, that was better. That was a lot better. I can handle that one. Now it's creeping away. Now it's coming back. Not ideal, but I think I see how to fix this. Now I do have other things I need to work on doing this evening. This is what we do over here at CosmoQuest. We work on putting science in your head. In this case, we work on destroying a planet with a star, because it's a thing to do on a Tuesday night. And I hope that all of you who are new will give us a chance and give us a follow. We do a lot of different things on this channel. This channel is actually one that is run by a nonprofit. We are part of the CosmoQuest collaboration, and CosmoQuest is a group of different institutions led by the Astronomical Society of the Pacific, and including the Planetary Science Institute and Youngstown State University and a bunch of others. And we use CosmoQuest.org as a platform where you can come and learn and help us map out the way too much data that's coming down from a variety of different spacecraft and help us do science. Check it out when you have a spare moment, when you're listening to a streamer that you're really listening to and not watching. Continue joining us over at CosmoQuest.org. Now here on Twitch, you'll see several different of us on this channel. I'll be back again tomorrow at 1 p.m. Eastern, 6 p.m. Europe, which is 10 a.m. Pacific. And I'm going to be bringing you a quick roundup of all that is new in astronomy and space science. So I hope I'll see you there. And yeah, we're sustained by you. Every subscription, well, keeps us going, and every bit really matters. So I want to do a quick shout out to all the new people who followed us and helped our show tonight. Noel, thank you so much for 3 months as a subscriber. Thank you for the follow, Honoris, Okawa, Warubu, Dat Dolphin, Neuropilot, One Immortal King, Much More Magic, Crimson, Wormdrake, the Hyper Blast 2. Thank you for your subscription. There was a noise. What was that noise? Thank you, Quinn Culver, for the follow. Thank you, the Hyper Blast, for subscribing. Thank you, Horizon Sai, for your raiding party. Thank you, DePriest15, for the follow. Thank you, Canada Kim, for the bits. Thank you, Paranor, for 3 months of subscribing. Thank you, Fenmill, for the bits. And can we get a light up of all those rocket shifts to thank everyone for joining tonight, and to thank everyone for your bits and subscriptions and support Oh, I clicked entirely the wrong button and got yelled at by Twitch chat. There we go. Let's light it up and make a whole fleet take off in the name of science. So I'm going to raid you guys over to a new channel and have a wonderful morning, evening, or afternoon, wherever in the world you may be. And I really hope I'll see you tomorrow. And I really hope you'll go outside and look up and know you can come back here to understand what you've seen. Bye-bye, everyone.